Hi friends, welcome to TTB once again. In this video, we will be looking at how to define the load cases and combinations in ETABS. So here we go. The complete model which we completed in the previous video, and now we will be applying loads to the beams, slabs, etc. etc. So before that, we'll have to define the load patterns. So connecting this dead load will set the self-weight multiplier will be 1 because dead load is automatically assigned to the model. Whereas live load, we will be applying this load. For this reason, it is given as 0. And other than that, we will be adding new loads in the name of SDL, that is superimposed dead load. So which will be under the category of super dead. So this will also be 0 add load. And we will be defining wall loads which will be super dead as usual. And we are adding this over here. So if we are doing static and dynamic analysis, we will have to define earthquake and wind loads. So let us define the earthquake loads first. So it will be QX, whereas this will be seismic. And in this, we will be designing an Indian code. So select the code as IS 1893 and add new load. Don't forget to modify the lateral load over here, in which we will be giving at X plus eccentricity because it will be having higher ratio compared to X direction and X direction minus eccentricity. So the story will be ranges from base to story 4 as said. Response reduction factor. For this, we'll have to refer IS 1893, and these conditions will be for these conditions we'll have to look IS 1893. Only after that we'll be getting an exact. Let us set this time period as program calculated. Otherwise, in user defined, we'll have to calculate from IS 1893 2002 and enter the value over here. So just give OK, and also define EQY over here. Add new load and don't forget to modify the lateral load. Whereas in this condition, it will be X, Y plus eccentricity, and all these conditions remains the same. Just give OK till earthquake, or else if you want to add wind, let this be like this. So this will be under wind load. Over this it will be IS 875 part 187 add new load. And also where we'll have to modify this thing. Considering this area, modify this show, it will be 0 degree in X direction. Give OK. All these conditions depends on the soil type and the structure. So let this be default. For this you'll have to prefer IS 1875. So give OK, and don't forget that the exposure height will be story 1 to story 4. Just give OK, and also add wind Y. So over here the same will be applicable, but in this area it will be 90 degree. So give OK, and the rest will be default as said earlier, and just modify this as wind X. So modify the load. So we have defined all these load cases. Just give OK. Now over here we'll have to go to load combinations. In load combinations, we'll be have to refer IS 456 and IS 13920. Over there is a list of load combinations available for various combinations. That is 1 plus dead load plus live load plus 0.5 dead load, live load, etc. etc. We'll have to refer them and we'll have to add it. Over here, the first combination is default, that is 1. So dead load will be 1, whereas live will be 1, SDL will be 1, and also wall will be 1. This is the combination 1 we are giving over here, and select OK. Make sure that we'll have to enter 37 combinations for seismic analysis and dynamic analysis, whereas it will be 27 for static analysis. Just give OK. Have defined just one combination over here, and let us actually define the wall loads and apply over the beams and slabs. So let us go to the plan view of first story, and always ensure that it's only one story over here. Well, you can use this option, set display unit. It is a very helpful option while doing modeling. Over here you remove the joints. Since we are applying the loads on the beam, let beam be selected and remove everything. So what are all these options? I'll explain you in the upcoming videos. Let all these be the same. Just give apply and OK. So first floor is visible, whereas the same in all floors in one story. Okay, let us select this beam. This is selected. We will be applying a wall load of say 12 kilonewton per meter. So give assign. This is a frame, and over here frame load distributed, which will be wall load. Wall load will be 12 kilonewton per meter square. Just give OK. it is defined as 12. If you need it, just select this area, give show selected objects, right click show selected objects only, and set 3D. You will be able to notice the loads over here. So we can use this as 12 kilonewton per meter square, and also consecutively apply for every other thing. So let all the periphery areas have 12 kilonewton per meter square, whereas the internal areas be 6 kilonewton per meter square. We have selected the peripheries and give assign frame loads distributed wall load as 12, okay, and all these have been 12, whereas the internal will be 6 kilonewton per meter square, and there it goes 6 kilonewton per meter, sorry. And in 3D we'll be getting every other load possible over here. It is noted that over here there are no loads, and it is always, please remember this point, it is always recommended that you never select any object and assign loads in 3D view. It is safer option to just go to plan view and then select and give it. Also ensure that only 2 frames are selected over here. You assign similarly, it is distributed 6 kilonewton, since this is periphery it will be 12 kilonewton per meter. And just give this option show undeformed shape. It will be over here. This shows nothing but only the actual figures. So let us actually define the grid options and rename them. This will actually enable us to have a proper idea of which flow we are working at. First, second, third, and then the traverse. Let this be the traverse. Press OK, press OK. So in this area we can select this as similar. So that is what I mean is the first floor is similar to first, second, and third. Over here we can do this as first. So press OK, OK. So it is to be noted that when you select similar stories, since second floor is selected, if you just select this particular beam, all 3 floors are selected. Show selected objects only. 3D. You can see that first, second, and third, all these stories have been selected. So it is a better option, and I mean a quicker option to select all. Right click show all objects to view the all objects, and over here you can select all these and ensure that it's 51 frames are selected. So all these are internal and all these loads will be 6 kilonewton per meter. Just give 6 kilonewton per meter and now give OK. Okay. In 3D you can notice this all these internal beams have 6 kilonewton per meter. So similar case refers to the periphery. Just select all the periphery beams and press the exact loads. That is 12 kilonewton per meter. You can see that 42 frames are selected. Also go on the above floors. Just give this to remove this, and you can see that all the periphery beams are selected. So assign this as 12 kilonewton per meter. And it is to be noted that in terrace we usually have the parapet walls, so there is not much loads over inside, so only peripheries are selected. It is noted that it's a similar story, so only no similar stories refers to the terrace floor, so only this will be selected. Over here let us give a UDL of say 5 kilonewton per meter. Since only parapet walls are involved, it will be 5 kilonewton per meter. In 3D we can actually use all the loads of the beams. What the whole 3D model with the loads look like, and let us assign the slab loads, as this will be over here. Just go to the first floor, select this for undeformed shape, go to the check mark, just tick slabs, that is floors, and over here you can just select object fill, which will show the visibility of the floors, and just give OK, and the floors are visible. Now for the similar stories for first, second, and third, if we just select this one, this will be 3 shells. So selecting all, let us assume that we give a live load of 2 kilonewton per meter square. So assign shell loads, and over here uniform, that is live as 2 kilonewton per meter square. Just give OK. The 2 will be applied over here, second floor, third, but in terrace it will not be, as we have selected similar stories. So just select one story. In terrace the live load must be 3, since in the coming days there are many parties being organized at the terrace, so the live load, the moving load will be a bit higher. So let us give us a live load as 3 kilonewton per meter square. This is what the 3 kilonewton per meter square, just OK. So it is over here. In 3D we can just confirm this over 3, 2, 2, 2, and everything is fine as we expected. And now let us apply the SDL on the terrace. So selecting all these floors, SDL and the terrace be 2.4 kilonewton per meter square. So assign it as 2.4 kilonewton per meter square. SDL means superimposed load. 2.4 kilonewton per meter square. It's over here. In 3D we can just check over here it's applied as 2.4 and the rest there is no any load. So select the second floor. Any floor can be selected. Once we select similar stories, all the three will be selected. So over here let us give it as 1.2 kilonewton per meter square, which is minimum, that is 0.75 kilonewton per meter, 0.75 meter filling. So this deal over here will be 1.2 kilonewton per meter square. Now it's given, let's just confirm it, and this is what the total loads being applied. So this will be the end of this video. The design and analysis will follow in the next video. Till then, like, share, subscribe to Twin Tech Brothers. Thank you.